Have you ever felt that pull, that deep yearning to go beyond what's known? To break free from the limits that seem to define our world? Well, our universe has a limit, a cosmic speed limit that dictates everything. It's the speed of light, a staggering 299,792,458 meters per second. For over a century we've been told nothing can exceed it. But what if that's not the whole story? What if there are whispers of something faster, something that defies our deepest understanding of reality? What if the universe holds secrets so profound they could shatter our perception of time and space itself? Think about your own life. Every moment, every breath, every thought is happening within the confines of this cosmic speed limit. It's a silent, invisible barrier that shapes our observable universe. Einstein's famous equation, E equals mc squared, isn't just a formula, it's a cosmic law. It tells us that to push anything with mass to the speed of light, you'd need an infinite amount of energy. Imagine trying to drain an ocean with a single teacup. It's not just difficult, it's fundamentally impossible within our current understanding. This isn't just a scientific curiosity, it's a profound truth that governs every star, every galaxy, every atom in your body. It defines what we can see, what we can reach, and how we experience the relentless march of time. But what if there are entities that don't play by these rules? What if there are particles that are born beyond this limit, always traveling faster than light, existing in a realm we can barely comprehend? This is where the story takes an extraordinary turn. Imagine a particle that's a rebel, a cosmic outlier. We call it a tachyon. It's a whisper from the very edge of theoretical physics. A particle so strange, so paradoxical, it challenges everything we thought we knew. Picture this. You're driving your car and you press the brake, expecting to slow down. But instead your car accelerates, going faster and faster. That's a tachyon. The more energy it loses, the faster it goes. It's like the universe is playing a cosmic joke, a profound riddle that makes us question the very nature of motion and energy. And here's the part that will truly make your mind reel. Tachyons don't have normal mass, they have what scientists call imaginary mass. Not negative mass, but imaginary. This isn't just a mathematical quirk, it means they exist in a reality where our everyday rules simply don't apply. This imaginary mass has staggering implications for causality, for the very idea of cause and effect. Could a tachyon arrive before it even left? Could a message sent by tachyons reach you before it was even sent? It's like receiving a text message from tomorrow, a glimpse into a future that hasn't happened yet. This isn't just theoretical, it's a profound challenge to our understanding of time itself. For decades, brilliant minds have been on a relentless hunt for these ghost particles. From the deepest cosmic ray detectors to the most powerful particle accelerators, we've searched. And while no definitive proof has emerged, the very idea of their existence forces us to confront the limits of our current knowledge. It's a testament to the human spirit of inquiry, a relentless pursuit of truth even when it seems to defy logic. But what if the answer to faster-than-light travel isn't about finding new particles, but about bending the very fabric of space and time itself? If you're finding this journey as captivating as I am, please take a moment to hit that like button. It helps us share these cosmic mysteries with more curious minds like yours. Now let's talk about shortcuts. Not shortcuts through traffic, but shortcuts through the universe. Einstein showed us that space and time aren't rigid, they're like a flexible fabric. And if you can bend that fabric, you can create tunnels, cosmic bypasses. These are called wormholes, often referred to as Einstein-Rosen bridges. Imagine you're an ant on a vast sheet of paper. To get from one side to the other, it's a long journey. But if you fold that paper so the 2 points touch, you can step across instantly. That's the promise of a wormhole. So, the challenge? To create a stable, traversable wormhole, you'd need something truly extraordinary. Exotic matter with negative energy density. We're talking about matter that weighs less than nothing. Matter that actually pushes instead of pulls. It's kind of like trying to build a bridge out of pure anti-gravity. Now, we've never observed such matter, but mathematically it could exist. The energy requirements are immense, almost beyond our comprehension, but, you know, the allure of these cosmic shortcuts continues to inspire physicists to push the boundaries of what's possible. And then there's the Alcubierre Drive, a concept that, honestly, sounds like it belongs in a science fiction epic, yet it's actually rooted in the very laws of general relativity. Proposed by physicist Miguel Alcubierre, this theoretical warp drive wouldn't violate the cosmic speed limit locally. Instead, it would create a bubble around a spacecraft, contracting space in front of it and expanding space behind it. The ship itself would remain perfectly still within this bubble, while the bubble itself surfs through space at superluminal speeds. It's kind of like being on a moving sidewalk that's going faster than anything you've ever seen. The energy needed for such a feat is, well, astronomical, demanding the equivalent of Jupiter's mass converted into exotic matter. Despite these colossal challenges, the Alcubierre Drive offers a tantalizing glimpse into a future where interstellar travel might actually be within our grasp, not by breaking the rules, but by cleverly, elegantly bending them. But what if our current understanding of physics is simply a small piece of a much larger, more intricate puzzle? What if there are other realities where faster-than-light travel isn't a distant dream but an everyday reality? This brings us to a concept that will truly broaden your understanding, the multiverse. What if our universe, with its seemingly unbreakable laws, is just one thread in an infinitely complex web? What if the very physics we consider fundamental are merely local rules within a grander, more expansive reality? This is the profound question posed by the multiverse theory, the idea that our universe is but one of many, perhaps an infinite number, each with its own unique set of physical laws and constants. In some of these parallel realities, the speed of light might be different. Or perhaps the very concept of a speed limit doesn't exist at all. Imagine worlds where civilizations traverse galaxies with ease, unburdened by the cosmic speed limit that defines our existence. This isn't just a flight of fancy, it's a concept explored by leading physicists and cosmologists, a way to reconcile some of the perplexing mysteries of our own universe. It suggests that our current understanding, while powerful, might be just a small piece of a much larger puzzle. The quest to understand the universe is not merely an intellectual exercise. It is a deeply human endeavor, driven by an insatiable curiosity, a desire to push the boundaries of what we believe is possible. From the earliest stargazers to the most advanced particle physicists, we are constantly striving to discover the cosmos's deepest mysteries, to understand our place within its vastness. This journey, filled with wonder and uncertainty, is a testament to the enduring spirit of exploration that defines our species. It is a reminder that the universe is far more intricate and mysterious than we can ever fully comprehend, and that every answer we find only leads to more profound questions. So what does this mean for our journey beyond light speed? Perhaps the answer lies not in breaking the rules but in discovering new ones. Perhaps the universe is waiting for us to expand our consciousness, to embrace possibilities that currently seem impossible. The pursuit of faster-than-light travel, whether through hypothetical particles, warped space-time, or the vastness of the multiverse, is more than just a scientific challenge. It is a reflection of our deepest aspirations, our yearning to connect with the unknown, to explore the furthest reaches of existence. It is a reminder that the greatest discoveries often lie just beyond the edge of our current understanding. The universe is calling. Are we ready to answer? If this exploration into the unseen universe, tachyons, and the possibilities beyond light speed resonated with you, please consider sharing this video with friends who are equally fascinated by the mysteries of the cosmos. And to continue discovering the mysteries and wonders of the universe, subscribe to Universal Insights. We invite you to share your thoughts in the comments below. What are your reflections on the light barrier, and what do you believe lies beyond?